This is MAP4C day 22A, and this is the first part of the first day of Unit 3, a little bit of review and preview material for Chapter 3, and it's review of old stuff, so hopefully it'll be pretty straightforward. So what type of graph is this? Well, we can see it's a bar graph, but each thing has two bars, so we call it a double bar graph. The best quarter, well, I think any way you measure it, we want to have high income for the best quarter, but if the expenses were higher than the income, we would probably say that the fourth quarter wasn't the best quarter. So the profit, highest profit, which is the highest difference between bars, but either way, I think the fourth quarter is the best. Estimate the revenue. Well, the revenue is the same as the income. It's same word. So the income in the third quarter was, if I went across here, around 70. Now notice, 70 is on the scale, but it's 70 in thousands, so $70,000 was the revenue in the third quarter. In the second quarter, notice halfway in between is about there, so this is maybe a little bit more than 100. And if you're within a couple of $1,000s here, that's probably acceptable. And maybe I should be using sentences, but we got a little double lesson today, 22A. There's 22B coming. Let's just keep moving here. And so the expectations today are to discuss graphical representations of data graphs. Saw a bar graph, double bar graph in the first one. We want to read 1 and 2 variable graphs. Well, this is what the second part is going to be all about, this difference between 1 and 2 variable graphs. Look at the given graph. What type of graph is this? This looks like a bar graph again, but it's not. This is actually a special type of bar graph, and the title is right there. It tells you it's a histogram. The difference is that the x-axis is a number line. It's a scale, right? You see there's a scale here that looks just like the y-axis is a scale. The x-axis is a scale, and compared to this, these were just labels of categories. This was like June, and this is March or whatever. They're just labels. Here, it makes sense that this is the x-axis. When that happens, we call it a histogram. Okay. And notice that it's the percent of, we don't know what exactly we measured, but this is the graph of histogram of length. So this is the length in microns, and microns is a small measurement of length. It's smaller than a millimeter sort of deal. Now, if we look at this, it says 0.72 microns is the midpoint of this second interval. Look, that tick is right in the middle of that second interval. So the question here is, what is the second interval? So this thing represents, parts or something that we're measuring in microns, widths of hairs or something, who knows. And we want to know what that interval is. The middle point is 0.72, but what is the interval? Well, I'm going to kind of draw a bigger copy of this so we can think about it. There's the midpoint of the first interval, and then over here somewhere is the midpoint of the second interval. And what we want to find is what these numbers are right here and right here. Well, how do we do that? Well, I'm going to get a different color. I see this amount, which is the width of an interval from midpoint to midpoint, is 0.12, right? So from here to here is 0.12. If I divide that in half, right there, that's 0.06, isn't it? Half of that, 0.06. So that means this is 0.06. So if I wanted to get what that spot is and that spot is, I would start at 0.72, go 0.06 lower, 0.06 higher, and then I'd have my interval. So the low was 0.06, 0.72, subtract 0.06, which is 0.66, and the high would have been 0.72 plus 0.06, and that's 0.78, and then the interval is 0.66 to 0.78, and notice 0.72 is the in-between point there. If I wanted to find the midpoint of this interval the way it's given, I'd add those two, divide by 2, and I get 0.72. It's all good. So what interval was the most common? Nice thing about a graph, I can see it right there. It's this interval, the one with the midpoint 0.44. But notice if I wanted to state the interval, I'm going to go 0.06 higher and 0.06 lower. 0.06 higher and 0.06 lower. So it's going to be 1.38 to 1.50. That's higher. And that one there is the most common interval. So most of them were in that middle one there. What are the longest and shortest times items that were measured? And notice we don't know exactly, because when it's lumped into these intervals, we don't know exactly, but it could be as low as there and as high as there. So how are we going to get that? Well, we'll take our midpoint, go a little bit lower than the midpoint, and remember half an interval is 0.06, so it's going to be 0.54, which is 0.6 subtract 0.05, all the way to the highest, 2.46. You take the midpoint there and add 0.06. So that's a pretty neat graph, that one. A histogram, not a bar graph. Next one is what type of graph? Circle graph. Or you could call it a pie chart, that's okay too. Which one was the biggest expenditure? The one with the biggest chunk of pie, which is housing. Didn't say how much, but it says estimate how much each American spent in the highest category. And this is the average expenditure. 1992, a little while ago, but it was 32% of the amount that they spent, which was 29,846. And so this is kind of like a grade 9% question. Percent as a decimal, of means times. Jam that into a calculator and you get that each American in 1992 spent around $9,550.72 on housing. Circle graphs or pie charts. This one is a different one. What type of graph is it? What is the circled point? Now there's no circled point, but I'm going to circle this one. So what type of graph? And you haven't seen this one since maybe grade 9-ish. It's scatterplot, right? Where we plot a bunch of points and we look for a trend line or something like that. We can see the trend line is going downhill. What does the circled point represent? Well, looks like the x-axis value is, I don't know, elevation. X-axis we read first, which is maybe around 1100, somewhere in there, and you could be close to that, still get the right answer. And then the y value is somewhere in here, maybe halfway between 17 and 20, maybe 17.5. And so it looks like it's got an elevation of 1100 and a mean annual temperature of 17.5. Now, what has those things? We don't know, but we know something has that. Something, question mark, has an elevation of 1100 meters and a mean annual temperature and a temperature of 17.5 degrees Celsius. And they're asking us to say what might each dot represent. And this is the idea of a graph being more powerful than the words, right? We've got all these things and we don't know what they are, but just from our ability to read a graph, we can say that represents something with an elevation of 1,100 meters, and a mean annual temperature of 17.5. The question here is what might each of these dots represent? Well, we got the state Nevada. Maybe it's towns. That might make sense, right? Each dot might represent different towns or cities in Nevada. Could be, could be anything. It could be weather stations or mountains or big trees or who knows. But probably like towns or cities. And this is a scatter plot of the relationship between elevation and mean annual temperature. All right, that's it for 22A. Do a little homework, and then we'll do 22B in a second. Now, 22B is a comparison between some of these graphs. There were two things involved in this graph, elevation and mean annual temperature, where over here we're only interested in the expenditure. One thing, one variable. Two variables, one variable. And 22B is a discussion about this. Okay?